Hey everyone, welcome to Integrated Medical Biochemistry with Dr. Bijoya. Today we will discuss the part 1 of alcohol metabolism. This is going to be a series of lecture and this is the first part. So let's begin. Now we'll talk in detail about the metabolism of ethanol. So this is uh, uh, how ethanol is ingested. It reaches the stomach and then the intestine. Now its rate of absorption depends on whether the person is fasting or he is well fed. If the person is in fasting condition, the absorption is quick, and if the person is well fed, then the absorption is slow. So once it reaches the circulation, then it will go into the liver, and in the liver, the metabolism will begin. So the first step that occurs is conversion of ethanol to acetaldehyde by the enzyme alcohol dehydrogenase. Now this reaction is taking place in the hepatocyte in the cytosol. So this is a cytosolic reaction where ethanol is getting converted to acetaldehyde and it is generating NADH. So it yields to NADH, which is a energy giving reaction. Now, once it is converted to acetaldehyde being toxic and it can easily diffuse into the circulation and reach various organs. So quickly it is taken up by the mitochondria and it is then converted to acetate by the second enzyme, that is aldehyde dehydrogenase. So there is one more NADH generated here. So there are two NADH, one is cytosolic and one is mitochondrial. So there is large number of NADH in the cytosol and large number of NADH in the mitochondria. Now once this step has taken place, this acetate can easily diffuse out. It can then be converted into acetyl CoA in various organs such as skeletal muscles and heart. And in these organs, it undergoes citric acid cycle and finally it gives carbon dioxide. This is the most common pathway and 80% of alcohol is undergoing this pathway. Now, if alcohol consumption is large, then the other two cell organelles come into picture, that is the peroxisome and the microsome. So basically there are three organelles that are participating: mitochondria, microsome and peroxisome. While mitochondria is carrying out most of the reaction, peroxisome and microsome get activated only when alcohol consumption is large because the enzymes have higher Km values compared to alcohol dehydrogenase. So let us see in peroxisome which is the enzyme. It is the enzyme catalase. Now this enzyme catalase will bypass the alcohol dehydrogenase step. So no NADH will be generated. Alcohol will be directly converted to aldehyde and it will also consume H2O2 and convert it to H2O. Whereas in microsomes, again this step is bypassed. So there is no formation of NADH. Okay, and this enzyme here is CYP2E1, that is CYP2E1. This is the enzyme here in microsome, which is a cytochrome P450 enzyme. It will convert ethanol to acetaldehyde and it will also use NADPH. As you know, NADPH is very important in uh, free radical pathway. It detoxifies free radicals. So this is consumed in this step. And Now aldehyde from both, anywhere, wherever aldehyde is found, whether it is in the cytosol, whether it is in peroxisome or in microsome, they will all come to the mitochondria. And the next step will be as such, as seen in the described earlier. So acetate is formed. From acetate, acetyl CoA is formed by different organs, and this is how it will get converted into carbon dioxide. This is the oxidative pathway. Now there's a second one, that is the non-oxidative pathway, which is occurring in this is also occurring in liver, and here ethanol is getting converted to phosphatidylethanol, or it is getting converted into fatty acid ethyl ester. So this is toxic, and it will give rise to free radicals or lipid peroxidation. And these are the organs that may be affected by the end products of ethanol metabolism, that is brain, heart, kidney, lungs, kidney, and intestines. So these are the organs that are affected. Now let us look at the harmful effects of acetaldehyde. So on drinking, when the ethanol is metabolized to ethanol, it causes various effects, which are toxic effects, and these effects are generally caused due to accumulation of acetaldehyde. So let us look at these effects. The first effect is caused due to the enzyme alcohol dehydrogenase. If the allele al alcohol dehydrogenase 1b2 is expressed, because of this allele, the alcohol is rapidly metabolized to acetaldehyde, and because of this there is accumulation of acetaldehyde, and it, this causes toxic effects. The second defect is in the enzyme aldehyde dehydrogenase allele 2, which is an inactive enzyme in general population, but if at all it is active, then there is 10 to 20 folds of higher accumulation of acetaldehyde, which again makes the alcohol intolerable. And the third effect that is caused is the hangover effect, which includes flushing, sweating, tachycardia, nausea, vomiting, and ethanol. These are the effects that appear acutely, but about the chronic effects we will discuss in our next lecture. Now let us see the impact of NADH, NADH to NAD ratio, and acetyl CoA on different pathways, which we just mentioned. We will discuss it a little more in detail. So the first thing that we discussed is that the glycolysis is increased. But how is it increased? First, we have to remember that breakdown of alcohol causes high concentration of NADH. So now the body will try to reduce this NADH because there's too much of NADH in the mitochondria and the cytosol. So the first mechanism is by dysregulating the glycolysis. So what will happen in glycolysis? That the conversion of 1,3-bisphosphoglycerate will not go forward into forming pyruvate, but instead it will reverse and form glyceraldehyde 3-phosphate. So here NADH will be consumed and one NAD will be released. So it will go in the opposite direction. That is the first change. And the second change is that the pyruvate, whatever pyruvate is formed, it will get converted into lactate, and again one more NADH is used. So the aim of these two changes or the modification is only to reduce the excessive NADH that is generated by ethanol. So one more NADH is used, and NAD is generated. But because of this, there is excessive formation of lactate. So the resultant effect is lactic acidosis. So that is the first impact. Second impact on TCA cycle is that malic acid to oxaloacetate. This step will also be reversed. This is a reversible step. So malate dehydrogenase will not convert malate to oxaloacetate, but whatever oxalate is there, it will be converted to malate. So there will be more of malate, and in this step, NAD will be the end product. So again, this mechanism is more pronounced because of excessive amount of NADH. So we see the impact of excessive amount of NADH and NADH to NAD ratio on TCA and glycolysis. Now let us see the next metabolic pathway that affects. So the next metabolic pathway is gluconeogenesis. Now we know that oxaloacetate to malate is converted in gluconeogenesis, and in the mitochondria then this malate has to reach the cytosol through malate aspartate shuttle because oxalate cannot move out, and this malate is now converted to oxaloacetate. So this entire pathway will be reversed so that NADH is consumed and it tries to balance this excessive NADH. So the gluconeogenesis will be reversed. So no gluconeogenesis will in fact be inhibited because of this. Now impact of high NADH again and acetyl CoA on fatty acid metabolism. So as you know that there is acid aldehyde is converted to acetate and acetate is converted to acetyl CoA. So there's increased concentration of acetyl CoA, and now what will happen to acetyl CoA because TCA is depressed? So the alteration in metabolism is that it will depress fatty acid breakdown, but in fact it will increase fatty acid synthesis. So fatty acid synthesis will increase and it cannot move out of the liver, so it will start forming droplets on the liver tissue itself. So fatty acid catabolism will decrease and fatty acid synthesis will increase. And the other product that will form is ketone bodies. Generally, it will be beta hydroxybutyrate. Now, ethanol metabolism occurs primarily in the liver depending on the ethanol concentration. As I told you, lower concentration of ethanol, if taken, then it is converted by, it is metabolized in hepatocytes. Enzyme is ADH, it has many isoenzymes. Its inhibitor is fomepizole. So this enzyme has an inhibitor and this may be used in the treatment for intoxication of ethanol. Mitochondria has the enzyme aldehyde dehydrogenase. It also has various isoenzymes and it converts alcohol to acetaldehyde and aldehyde to acetate. So the inhibitor disulfiram blocks this enzyme and it stops the conversion of acetaldehyde to acetate. The higher concentration of ethanol also occurs in hepatocyte, but the organelle changes here. The first step occurs in the microsome or the peroxisome. If it occurs in microsome, it is the enzyme CYP2E1, and when it occurs in the peroxisome, the enzyme is catalase. Both these enzymes bypass alcohol dehydrogenase step. So no NADP, no NADH is generated, whereas in this low concentration of ethanol, two NADs are generated, one in the cytosol and one in the mitochondria. So let us look at the complications due to alcoholism. It can be of two types, acute or chronic. Acute complications generally include alcohol intoxication, alcohol withdrawal, and chronic complications of alcoholism includes the impact of alcoholism on different organ systems. So all this will be discussed detailed in the second part of the lecture. So hope you liked what I presented before you. So for more videos, like, share and subscribe, and don't forget to hit the bell icon. Thank you. Have a nice day.